In lesson 26, we're going to look at percents of a quantity. Example 1 says that 5 of 25 girls on Alden Middle School soccer team are 7th grade students. We need to find the percentage of 7th graders on the team, and we need to show 2 different ways of solving for the answer. One of those methods must include a diagram or a picture model. So we'll start off by making equivalent fractions. They told us that 5 out of 25 girls are 7th grade students, so our original fraction is 5/25. Then they ask for the percentage. So to make an equivalent fraction, we would need something out of 100. In looking at these two fractions, what we need to do is determine what we can do to 25 to get 100. And that can be determined by dividing 100 by 25, because you can multiply by the same number in both the numerator and denominator, or you can divide by the same number in both the numerator and denominator. In this case, since we are getting larger from 25 to 100, we would be multiplying, and we'd be multiplying by 4. Whatever we do in the denominator, we must do in the numerator as well. So we will multiply by 4 in the numerator, and that will give us 20 100ths. 20 100ths is 20%. So we have found our answer numerically. We also have to include a diagram or a picture model. So we'll do a double number line. When we are setting up our double number line, we need to have the percentages divided equally on one part, and we need to have the number, the total number, divided equally on the other part. So I've set up 0% and increasing by 20 percentage points each. So 0 through 100% on the top. On the bottom, again, we would start at 0, and our top number needs to be 25. We know that because that is the total number of girls on the team. So when we look at the divisions, we can see that we have 1, 2, 3, 4, 5 divisions to get to 25. So we'll divide 25 by 5, and we will increase by increments of 5 along our number line. There we have our double number line. And then we can take a look at where the 5 out of 25 mark sits, and that is 20%. Continuing on to example 2, we are again talking about the 25 girls on the Alden Middle School soccer team, but now we're saying that 40% of those girls also play on a travel team. And they ask how many girls on the middle school team also play on the travel team. Again, we need to represent this 2 different ways. So we'll start off numerically. They've given us the percentage, and a percentage can be written as a fraction. So we will write it as 40 100ths. And they have not told us the part. They've given us the whole. The 25 girls on the middle school soccer team is the whole team. So the part is what we're missing. Again, our whole, The 25 girls on the whole soccer team goes in the denominator. Now in this case, we can see that we're going from 100 to 25. So we're getting smaller, which means we would need to divide. To figure out what we're dividing by, it's just as easy to take 100 and divide it by 25, which we would find is 4. So 100 divided by 4 equals 25. And whatever we do to the denominator, we have to do the same thing to the numerator, which means that our numerator would need to be 10. Looking back at the question, how many of the girls on the middle school team also play on a travel team? 10 girls play on the travel team. Next, we have to represent this with a diagram. And we'll use that double number line diagram again. It seemed to be a pretty good choice before. Since our numbers in this example are very similar to our numbers in example 1, we can have the same intervals from 0% to 100% and from 0 to 25, since we still have the same number of girls on the team, 25. The equal intervals would have us going by 5s. And then, since we're looking for 40%, at the 40% mark, we can see that there are 10 girls who play on a travel team. In example 3, we are still talking about the girls' soccer team, but this time we're talking about how many games they have won. They are giving us the percentage. So we will write that percentage as a fraction. And then they tell us if the team won 12 games. How many games did they play? In the first sentence, it told us that the girls' soccer team won 80% of their games this season. So if they only won 80% of their games, and that number was 12 games, the 12 would have to be the part, not all of the games. So we'll put the 12 in the numerator, the same as our 80 for the 80%, because 12 represents part, not the whole. Which means in this case, we're actually looking for the whole. We're looking for the number that represents 100%. In this example, however, 12 does not go evenly into 80. If we do that division, it is a repeating decimal, which isn't going to serve us very well. However, 80 100ths is a fraction that can be simplified. And if we simplify it, there's a pretty good chance that we will be able to make equivalent fractions more easily. 80 100ths could be simplified to 8/10, but 8/10, just put some of our work down here. But 8/10 can also be simplified. If we divide both 8 and 10 by 2, we would get 4/5. So coming back up to our original ratio, four-fifths, when we try to get from 4 to 12, we can see that 4 times 3 equals 12. And again, whatever we do to one part of the fraction, we have to do to all of the fractions. So we would multiply 5 times 3 to get the denominator. And we find then that the girls played 15 games. As we did in the other examples, we're going to have to represent this problem with some kind of a diagram. So we'll make a double number line again. And we'll take our 100% and split it into 5 parts, 20, 40, 60, 80, 100%, just like we did in the other 2 examples so far. We know that we have to start at 0 for the actual number of games. And we know that we have to get to 12. We have to get something past 12, however. We know that 12 is the 80% mark. So to get there, we have 1, 2, 3, 4 parts. That would mean then that we should go by 3s, 3, 6, 9, 12, because we have 4 spots to fill to get to the number 12. If our pattern is counting by 3s, then at the 100% location, we should be at 15. Again, we determined that we had 1, 2, 3, 4 divisions to fill before we could get to 12. So we took 12 and we divided it by 4, which was 3 for each division. And so we used that pattern to fill in each of those spots and then continued the pattern to get to 100%. In exercise 1, we've changed our numbers a bit in our examples, and now we're talking about the animal exhibits at a local zoo. They're asking what percent of the zoo's exhibits each animal class represents. First of all, the important numbers start out with the total number of animal exhibits, which they gave us in the introduction. There are 60 animal exhibits. So each of these individual animal exhibits are out of 60. Knowing that, if we were to say 30 60ths for the mammals, 15 60ths for the reptiles and amphibians, 12 60ths for the fish and insects, and 3 60ths for the birds, we could then take those fractions and simplify them and use that simplified fraction to find our percentages. 30 60ths is 1/2, which is a very common percentage of 50%. 15 60ths is 1/4, and that also is a pretty common fraction or percent of 25. 12 60ths is 1/5, which is 20%, and 3 60ths is 1/20th, and that is 5%. Exercise 2 gives us the price for a sweater. The sweater was regularly $32, and it's 25% off the original price this week. The amount the shopper saved would be considered a part, because the whole price would be the price the sweater was regularly. The shopper would save, and we need to determine that, 25%, which as a fraction would be 25 over 100, And what we need to know is how much that savings is. So we'll be missing the numerator of our second fraction. In the denominator of our second fraction would be the whole price of the sweater, which is $32. It is $32 regularly. Looking back at the two numbers that we have that match, our 100 and our 32, we can determine pretty quickly that 32 doesn't go into 100 neatly. But we also know that 25 100ths can be simplified to 1/4. So we'll do that first. And then looking at the two fractions, 1/4 and something over 32, we can see that 4 times 8 equals 32. And then in our numerator, we would simply multiply by 8 as well, which would give us 8 in the numerator. This part is the $8 savings on the sweater. So the shopper will save $8. Representing that in a tape diagram or in a double number, to determine the intervals that we would separate our number line into, we would want to take a look at our original fraction after we simplified it, which was 1/4. So we're going to divide our percentages into fourths. And we know that if we are dividing 100% by 4, each division would need to be 25%. And then our numbers on the bottom part of our number line would need to go from 0 to 32, which is our regular price. And we have 4 divisions, so we would take 32 and divide it by 4, giving us 8 at each division. $8, 8 more is $16, 8 more is $24, and 8 more is $32. And we can see easily then that 25% of 32 is $8. In exercise 3, we have another percentage off price, but in this one it's a little different. It says the pair of jeans was 30% off the original price. The sale resulted in a $24 discount. So part A asks us, is the original price of the jeans considered the whole, part, or percent? The original price would be the whole. And the original price is what we're looking for. Part B asks, what was the original cost of the jeans before the sale? So we are looking for the whole. They have given us a percent, 30%. And they've told us that the discount, the 30%, was $24. 30% is 30 over 100. And of course, the original cost, the whole, is what we're looking for. Looking at 30 and 24, we can see that they do not easily divide with each other. But we also know that 30 100ths can be simplified to 3/10. So we'll make it 3/10. And then we'll look at the relationship between 3 and 24. 3 times 8 is 24. So we will multiply 10 times 8 as well. And that will tell us that the original price of the jeans was $80. To represent this on a double number line, we would start with 0% again. And looking at our simplified ratio, we can see that we will need 10 pieces in our division. 100 divided by 10 is 10%, so we will increase by 10% each time. And then in our prices, we know that 30% is a $24 discount. So looking at 30, we can see that we are going to go 1, 2, 3 steps in our number line. So we'll need to take the $24 and divide it by 3. 24 divided by 3 is 8. So at each division, we will increase by 8. $40, $48, $56, $64, $72, and finally 100% is $80. Our final exercise 4 says purchasing a TV that is 20% off will save $180. We're going to name the different parts with the words part, whole, and percent. 20% off is the percent. $180. Purchasing a TV that is 20% off will save $180. So $180 must be the part. And the original price, which is what we don't know, is the whole. The question then is, what was the original price of the TV? That's the part that we need to find. So our percentage, which we already know, would be 20 over 100 as a fraction. We know the part, which is $180. And we are looking for the original price, which would be the number that matches with 100%. Looking at 20 and 180, we can see that 20 does go into 180 easily. It goes in 9 times. So if we multiply the numerator by 9, we also need to multiply the denominator by 9. And we'll find that the original price of the TV was $900. And making a double number line one last time, we'll start at 0%. And we will need to make our division. We'll need to make our divisions go by 10, because if we simplified this fraction to 2/10, that would be more reasonable to put on this double number line. And then for the divisions and our actual numbers, starting at 0, we would need each of our divisions to reflect 10%. And since our discount was 20%, and that discount was $180, 20% is equal to $180, we could divide 180 by 2, because there are 2 divisions to get to 20%. And 180 divided by 2 is 90. Again, we divide it by 2 because there are 2 divisions to get to 20%. And then we will increase by 90s following the pattern. 4 times 90 is 360, 5 times 90 is 450, 6 times 90 is 540, 630, 720, 810, and finally 900 would be the full price of the TV.